In this particular question, we've been asked to find the point on the line y equals negative x squared minus x that is closest to the point 1, 2. Now, we've previously looked at this question and solved it using differential calculus, but some of you may have realized that there was an alternate approach that didn't involve using any calculus at all. Let's start by just making a rough sketch. We have our linear function, which has a y-intercept of -1 and a slope of -2. I've plotted that. And I've plotted my point 1, 2. Now, I've plotted one potential point on my linear function. I've plotted it with a little green dot, or a little green point. And using the green marker, I've drawn a dotted line that represents the distance between that point and our point 1, 2. Below, I've done the same thing. I've plotted a point on our linear function, and using the green marker again, I've illustrated the distance between that point and 1, 2 using a dotted line. What you'll notice is that neither of the lines that I've drawn in represent the shortest distance between a point on the linear function and our point 1, 2. What you should realize is that the shortest distance would be created by forming a line that is perpendicular or at a right angle to our linear function. And I've done that using my blue marker and putting in a dotted line in that case. And I've labeled that point xy. Now, since the slope of line 1, that is our linear function that we started with, is equal to -2, and we know that the two lines are perpendicular to each other, therefore I can say L1 is perpendicular to L2, then I can conclude, or therefore the slope of line 2 must be equal to 1/2, because lines that are perpendicular to each other should have slopes that are negative reciprocals. So now I'm trying to find the equation of line 2, my dotted blue line. I know that its slope is 1/2, so I can write the equation to this point as being y is equal to 1/2 x plus b. I need to find b, the y-intercept. Well, I know that this particular linear function passes through the point 1, 2. So I can substitute 1 in for x and 2 in for y, and that allows me to solve for b, and I find that b, or my y-intercept, is equal to 3 divided by 2. So now I know the equation of this particular linear function. It's y is equal to 1/2 x plus 3 divided by 2. Now what I'd like to do is find the point of intersection between line 1 and line 2. And that point of intersection is the desired point xy. I'm going to do this by substitution. So I can say that -2x minus 1 is equal to 1/2 x plus 3 over 2. In the next line, all I've done is multiplied everything on both sides of the equations by 2. That way I don't have to work with any fractions. So I end up with -4x minus 2 equals x plus 3. I can solve for x. X is equal to -1. And then I use my equation of my linear function y equals -2x minus 1. I substitute in my x value of -1, and I find my corresponding y value is 1. I could have used the other linear function, y is equal to 1/2 x plus 3 over 2. I just decided I didn't want to work with fractions. So my point of intersection is -1, 1, and that represents the point on the line y equals -2x minus 1 that is closest to our point 1, 2.